All right, guys, we're continuing with confidence intervals today. And so the challenge is that there are several types. I think you probably understand the idea behind it. It's okay if you couldn't like tell that to your best friend, like this is what a confidence interval is. But I want you to see that underneath there are ideas that are really not all that complicated. But where we get in the challenge is this is going to be our third type of confidence interval. And when at the end of this, I'll talk about how to tell the difference between them, which is the most important part when you're being tested on this. Okay, so we've learned this. This is the first type of confidence interval. And on our calculator, we called this Z interval. And we learned a second type where we were dealing with proportions. Now today we're going to learn another type, and here is how it goes. It's called a T interval. And here's the story. So if you see here, we're following the same basic pattern, but what are some of the changes? The reason this kind of interval, confidence interval, needs to exist is this. We were looking in this confidence interval, we are looking to try to find the true mean for some population. Like all the Finley students, their average on the entrance exam. I'm trying to find that. This is what this kind of confidence interval creates. But there's a flaw here. And if you think about it for a minute, it should make some sense. This here, this sigma, this is the population standard deviation. So that's a parameter. In other words, if I was looking for this, how in the world would I know this? This is the true average for everyone in the entire state of California or everyone at Finley, whatever. Its partner is the standard deviation. So if I'm looking for this, how in the world do I already know the population standard deviation? I wouldn't know that. So this is not very practical in the real world. What is more practical is this. I don't know the population standard deviation, so I substitute in this S. S is the standard deviation. It's a statistic. It's from my group of people. So suppose I used you guys, this class, as my estimate for how people did on an entrance exam at Finley. I take all 25 of you, add up your score, divide. That's my guess at what the truth is for the mean. But I don't know sigma. I don't know the population spread. That's too unlikely. So what I do instead is I use your standard deviation. There were 25 of you. I added up your score to find your mean. But you also have a spread. Those 25 people are spread out in some particular way. So that's S. There is a standard deviation for my sample. So this is called a T interval. We are substituting S because in the real world, we probably don't know sigma. Now, there's one other change you'll see there's this T star versus Z star. Well, Z star is the length of that stick on the perfect curve. What's T star? Well, when we substitute S instead of sigma, we are no longer working on a normal curve. It's very close. It's called a student's T curve, and it is very, very similar. It has the same general shape, but it is not exactly a normal curve. So what we have to do is figure out we are working on this different curve. It's got one other twist called degrees of freedom. There's kind of a lot to the story behind degrees of freedom, but here's the basics that we need. This T curve, again, it's very similar, but it'll have a little bit kind of steeper peak in there. It changes based on your sample size. Every one of these curves, if you sample 50 people, this is a little different. If you sample 5 people, it's a little different. It keeps changing. So if you want to correctly make your stick here, this interval here, the margin of error, you have to know which curve you're on. It keeps changing depending on how many people are in your sample. So if you were looking on a chart, you'd find it by something called the degrees of freedom. It is the number of people in your group, take away 1. So if there's 25 people in the room, we would be looking at the curve for 24 people. You following what I'm saying? So if I had 10 people in my sample, the curve for 9 is not the same as this curve for 24. So I have to know which curve that I'm working on because they're all slightly different. But other than those two changes, we're doing the same exact thing. I got my point estimate, got my point estimate. Got the length of my stick on a different curve this time, but the length of my stick. I've got the standard deviation here for this sampling world, standard deviation for my sampling world, where I'm subbing in something more realistic for something less realistic. Okay, so if you're ready to do a problem, here we go. So if you look on your calculator, go to stats, you'll go down until you find this time t interval because we're working on this t curve. Now let me see what problems I got here. Let's do one of these. Okay, so look at what's different this time. A sample of size 15, so there's my n. I've got a sample mean of 35, and I've got a sample standard deviation of 14. We want a 95% confidence interval. I don't know if I have the answer to this here. I do. Okay. So crunch that. So remember, I left this out of a former video, but when you go to t interval, you've got data, which would mean you could put in all the individual people in your group. You could put all 15 people in, and then it would crunch x bar for you, and it would crunch s for you here, the sample standard deviation. But go over to stats. Most of our questions will be stats, and I don't remember the order that you'll put these in, but these are the things you need to tell it. And then you should, sorry, this is crazy. I think you're just out of room here. Now this was done by hand, so you might have a little different rounding, but you should have an interval between 27.2 and 42.8. Okay, something close to that. So the idea is the same. We're just working on a slightly different curve because we're using the sample standard deviation instead of the population standard deviation. Okay, this is just showing you what I just did. T interval, go to stat, put your stuff in here. Now we could do some more. I think the slides will have more done, but just you interpret, I'm going to skip those. That's what the activity does. Look through the slides if you need them, but we're interpreting a confidence interval just like we always did. I am some percent confident that the true population parameter is between here and here. And the population parameter changes based on the story. And if you're getting the hang of it, put it in there. We're looking for the true mean of students on the entrance exam at the University of Findlay, whatever. That could be replaced. All right. Now, there's a bunch of questions here. I don't know if all the answers are here or not, but this is where I want to take you. So we'll work on some in class and you can feel free to ask. But now here's the point that we're going to talk about more detail tomorrow. I have this here, and this is a little overwhelming this way. I prefer that you put this in the back of a notebook someplace. This is what I want you to do. The end problem with this test is that there are going to be so many versions of confidence intervals and so many versions of what's next called hypothesis testing. This is my strategy to help people understand what's going on. So imitate this chart. You don't have to write the formulas down, but what I want you to write here, and you don't have to do the sample size ones. I think it'd be better if you left that off. This is fair game for the test, but I'll talk more about that later. So there are 3 worlds that we've talked about. So put those worlds down the side, and then you've got along the top 2 different types of problems we're going to do. Confidence intervals, and our next section, hypothesis test. So over here is keywords. What separates one type of problem from another? And so let's look at that. I've got the Z world, the proportion world, and the T world. Now, first of all, when we get into hypothesis testing, we'll talk more about this, but a confidence interval problem always says confidence interval somewhere. It has to. It has to say confidence interval somewhere. So far we've done these, and every problem that you have done has somewhere said confidence interval. Now, the difference between what I call the Z world, the proportion world, and the T world is this. If you have a standard deviation that is all-knowing, it is about the population, it's as if you're God and you know the spread of this distribution for everybody at Findlay or everyone in the state of California. If you have that all-knowing spread, you're in a Z world problem. So you would be doing Z interval. Now the keyword for proportion, it might say proportion. That's not the best way because there can be some tricky things in some of the problems that'll mess you up. I think the best way is out of. When you read a proportion problem, and we're going to practice more of this tomorrow, but if you look back at the last section, you'll see that it either literally says 15 out of 30 people, 75 out of 120 people, or if it didn't literally say that, you could easily see that there's some number that goes over each other. 82 over 157. There was some proportion, some out of that could be there, even if it didn't completely say 82 out of 157. If you've got that proportion, then you're doing the proportion world in a one prop z interval. And then lastly, what we learned today is that we have a standard deviation that's from the sample. So we took this from our group of 25 people. It was from our sample. So here's how I would look through a problem. First of all, I'm looking for where the standard deviation came from. Is it all knowing, or is it from my sample? Is it S or sigma? And if you can't find standard deviation at all, you probably have out of, and helps you tell that third world. So I recommend you make this chart. You got this along the top, put in your keywords. You don't have to put all the formulas, but put Z interval, one prop Z interval, and T interval, and then understand how these keywords work. Okay, so look here. These are all going to be S because this is the section I'm in, but look at this question. It says I want a 95% interval, so I know I'm doing a confidence interval. And it says, here was my sample mean wait time with a sample standard deviation of 4. Well, that's S. I'm looking for standard deviation to tell me what problem. That's S. Well, this is T world. Okay, what else we got? Now this one, I wouldn't do this to you very much, but if you look through here, I've got a confidence interval and I've got all the data. Well, if I'm going to have to find this data and find my X bar, I'm also going to have to use S, my own standard deviation, which makes this T world again. Okay, now look at this one. These are all S, but there's different versions of how you see it. So confidence interval, and then there's a standard deviation right here. Well, where did the standard deviation come from? It doesn't tell me whether or not this is sigma or S, or does it? So look, let's see. They sampled 8 of whatever these things are, and here's the mean, and here's the standard deviation. Do you see the standard deviation came from the sample of 8? Do you see that? It came from the sample. It's S, and it's the T world. Okay, we'll talk more about this tomorrow, and this will be the focus as we go forward. But this is how you differentiate. And remember, this is a new kind, the T interval, and it's based on a sample standard deviation. Hope that helps.